starting chapter 12. We're going to be starting with 12.2, and we're looking at what's called an arithmetic sequence and an arithmetic series today. You're going to need your cheat sheet handy. We're going to have two formulas you'll be adding on your cheat sheet, and again, we've got some definitions that you'll need to write down as well. First up is the definition for an arithmetic sequence. A sequence whose consecutive terms have a common difference, and that common difference is labeled with the letter D. Terms would be any item in a sequence. First couple questions that you're going to see will be just a basic, is this arithmetic? Well, if something is arithmetic, that means it has to have a common difference. So what I want you to do, difference, remember, means to subtract. What I want you to do is subtract backwards. You want to be able to subtract backwards with consecutive terms. That backwards subtracting number is the D value that we need. So you're going to subtract backwards. 3 minus 0 is 3. 6 minus 3, 9 minus 6. We get the same thing every single time. So yes, this is arithmetic. Next one, 4, 9, 14, 19. Again, you have to subtract backwards. 9 minus 4, 14 minus 9, 19 minus 14. We get the same thing every time. So again, this answer is also yes. Number 3, 5 minus 3, 9 minus 5. We get 4. We don't get the same thing. We can stop right there. This one is not arithmetic. If you discover that a set of numbers, a sequence of numbers is arithmetic, we can write an equation for that. And the term we use to decide that it is an arithmetic equation, it's called an explicit formula. Your explicit formula is in this notation right here. A sub n, subscript right here, A sub n is equal to D times n plus A sub 0. Now this equation in the arithmetic form is the exact mirror image of our slope-intercept form. Y equals mx plus b. M is the slope, what it's changing by, a consistent change by every single time. And b is considered the y-intercept. It's the place where your curve crosses the y-axis. So our b term is exactly the same thing as our a sub 0 term. Now here's where you have to be very careful. Your sequence that you're going to look at does not start with the a sub 0 term. It actually starts with the a sub 1 term. So the first term is 0. The second term, a sub 2, the second term is 3, and so on. For this one, the first term is 4, and the second term is 9. We have to go backwards to figure out where it came from. In other words, where does it cross the y-axis? What is the a sub 0 term? We're going to actually have to go backwards. Follow your same pattern going backwards to figure out what that a sub 0 term is. Okay, so this first equation right here needs to go on your cheat sheet. Make sure you write the words arithmetic sequence to go with it. Arithmetic explicit formula, a sub n equals dn plus a sub 0. So now let's try to write the equation for those first two that we said the answer was yes, they are arithmetic. Okay, and I wrote the formula on here for you. A sub n equals dn plus a sub 0. Now if you remember, we went backwards and got 3 every single time. That's our d value. Our d value is going to be 3, so we're going to be putting a 3 right there, what we think the d is. So we'll have a sub n is equal to 3n plus, but now I have to go backwards. If I follow this same pattern, but instead of going up 3 every time, go backwards 3, this is actually going to change to a negative sign. This will be a negative 3 if I go backwards. So it starts at negative 3. That's my a sub 0 term. There's my formula. Once I have my formula written, then they're going to ask you to find any obscure number down the line in that list. In this case, they want a sub 15. I'm just going to take out my n and put in a 15. 3 times 15 minus 3, 42. So the 15th term has a value of 42. When you do the equations in this particular chapter, I will not give you credit if I see you doing this. 0, 3, 6, 9, 12, 15, 18, 21, and you're going to keep going until you get to the 15th term. 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th term right here. If you keep going like that and make a great big list and then figure out what the 15th term is, you will get 0 credit for that. I need to see your equations used in this particular chapter. Our other example on that page that we said was yes, arithmetic, was this one. Common difference was 5. I need to write the equation first. A sub n is equal to 5n plus, now I have to go backwards. So instead of increasing 5 every time, I have to go backwards 5. My a sub 0 term is negative 1, so I can put that in as 5n minus 1. And then we can go ahead and find the value of the 25th term. A sub 25 is equal to 5 times 25 minus 1, 125 minus 1, 124. All right, let's do this next one. This is a new example. 60, 52, 44, 36. Remember, go backwards. 52 minus 60, negative 8. 44 minus 52, negative 8. Negative 8. So our common difference is negative 8. A sub n is equal to negative 8n plus, now let's go backwards. Follow the pattern. So instead of going subtract 8 each time, I need to add 8 to come backwards. 68 will be my a sub 0 term, plus 68. So there's our explicit equation. A sub n is equal to negative 8n plus 68. And now I need the value of the 9th term. A sub 9 is equal to negative 8 times 9 plus 68, negative 72 plus 68, and our answer is negative 4. If we know one term and the common difference, we can write the model for that. Now remember, our model is our formula, a sub n equals dn plus a sub 0. So in this particular instance where we have one term and a common difference, we're going to plug in the values into this equation. Now we actually have 4 spots here that we can fill in. We have the value of the answer. D, remember, stands for your common difference. N stands for what term you're on. And a sub 0, of course, is that go backwards term. Where did it actually come from? So I have 4 spots to fill, and what they've done is given us 3 answers. A sub 27, that tells you that you're on the 27th term. That's the n value. 263 is the value of the overall answer. That represents a sub n. And then common difference is 11. 11 is going to go into our D position. So what I'm going to do is just replace these 3 numbers up in our equation. A sub n is 263 equals, common difference was 11. The n value, we're on the 27th term. And a sub 0 is the one thing I do not know. That's what I need to solve for. 263 equals 11 times 27. 263 equals 297 plus a sub 0. And when you subtract on both sides, negative 34. You have what you need now to write your equation. Your model, a sub n is equal to, common difference was 11, so it'll be 11n, and then our 0 term is negative 34. There's your model. Okay, let's try that again with this next equation. A sub n, that tells you what term you're on. That's the n value. Negative 57 is the answer, the a sub n value, and then of course negative 7 is d. Negative 57 is equal to, common difference, negative 7, times n. N is the value of the term that we're on. We're on the 11th term, plus a sub 0. Negative 57 equals negative 77 plus a sub 0. Add 77 on both sides. 20. 20 is our starting values, the a sub 0 term. Our model will be a sub n equals d, negative 7, negative 7n, plus a sub 0, plus 20. There's your model. If they give us 2 random points, we can still write the equation. Now, since this is arithmetic, this is what's really nice about the arithmetic sequence. The arithmetic sequence, remember, is the perfect mirror image of our mx plus b. A sub n is equal to dn plus a sub 0. The m and the d, the slope and the common difference are the same thing. So if they give us two random points, we can treat those two random points as two ordered pairs, and we know how to find the slope between two ordered pairs. That slope represents your d value. So if they give you two random points like this, a sub 7 equals 27 or 26, that represents the same thing as this ordered pair. The 7th term has a value of 26. Likewise, the 16th term has a value of 71. I can just do my slope. 71 minus 26 over 16 minus 7. 45 over 9, 5. That's my d term. Now I can go back and I can use either one of these 2 points. You can use this one if you want. And now we're back to what we did on that last slide. We've got one random point and our common difference. We can plug it into our model into the positions that we know. Let me write the model again so we know where we're going to put things. The value of the answer, in this case we're going to pick the 26. Common difference we just found is 5. The value of the term we're on is 7 plus a sub 0. 26 equals 35 plus a sub 0. Subtract 35 from both sides. Negative 9 equals a sub 0. And now you have everything you need to write your model. A sub n equals 5n, common difference is 5. 5n subtract 9. And again, once you find that model, they might ask you, okay, now can you tell me any other point? They might say, okay, what's the 12th point? All you have to do now is plug in your 12. 5 times 12 minus 9, and so on. But you can't do any of this, of course, until you get your explicit formula. Right? Let's try one more of these. 2 random points in the line. 10, 148, 44, 556. Calculating our slope gives us our d value. 556 minus 148 over 44 minus 10. 408 over 34, which is 12. There's your common difference. Let's use the first term. The value of the answer, 148 equals d, which is 12. What term are we on? 10 plus a sub 0. 148 equals 120 plus a sub 0. 28 equals a sub 0. Then we can write our model. A sub n is equal to common difference, which is 12, 12n plus the answer we just got, 28. All right, then we go to our second equation in this chapter. There are 5 equations we'll be looking for. Second equation is what's called an arithmetic series. An arithmetic series is the terms of a sequence that have been added together. So what we are looking for is the sum. Terms of a sequence added together. We want to try to figure out the sum of a certain set of numbers. And we have this formula that we use. Capital S, standing for sum. Capital S sub n is equal to n, parenthesis, a1 plus an, close the parenthesis, and divide by 2. What do these numbers mean? N refers to how many terms. How many terms are we going to add together? A sub 1 refers to the value of the first term. A sub n refers to the value of the last term in your sequence. And then the whole thing will divide by 2. So this formula needs to go on your cheat sheet, and then obviously in your notes to refer to. We have a notation, mathematical notation that we use to look at this particular question. This is called sigma notation. It's also called summation notation. This right here is the Greek symbol sigma. It means the sum of. What we do is put the values of which numbers we want added together. So if I want to start with the first term, I put a 1 down here. And then up on the top will be the nth term. So how many terms are we going to add together? You will see a number up here. Might be 10. In other words, I'm going to add from the first to the 10th term. What am I adding together? this thing, and this is the explicit formula that we just got used to writing in the previous slides. So your explicit formula will go in here after you see the symbol sigma. Well, how do you solve this? We solve it by using our formula. Solve it with this. N times A1 plus AN, all dividing by 2. All right, let's try a couple samples. And I wrote the sum formula up at the top of the slide. This notation, and this is exactly what your questions are going to look like in your book. There's going to be no words here, so you need to know what this symbol means. Find the sum of the first 8 terms according to the rule 3n minus 3. Find the sum of the first 8 terms according to the rule 3n minus 3. Well, how do I do that? With this formula right here. I need to say this, n. How many terms are in my sequence? Well, I'm adding the first to the 8th term. That's 8 terms. And then I'm going to multiply by the value of the first term plus the value of the last term. How do I get those numbers? Very easily. You're going to take whatever they start with down here. So if they want you to find the first term, take a number 1 and put it right there and solve. What's 3 times 1 minus 3? 3 times 1 is 3. 3 minus 3 is 0. That's the value of the first term. Plus, now take your last number, which is 8, and put an 8 right there and solve. 3 times 8, 24. 24 minus 3, 21. And then the whole thing divides by 2. 0 plus 21 is 21 times 8, divided it in half, and you should get 84 for an answer. So the sum of the first 8 terms is 84. Next one. The sum of the first 14 terms according to the rule 5n minus 1. N, first term, last term, whole thing divides by 2. How many terms are we adding together? 14. The value of the first term, take a 1, put it right there. 5 times 1 minus 1. Plus, take 14 and plug it right there. 5 times 14, subtract 1, 69. And the whole thing divides by 2. Hopefully you will get 511. Now on this next slide, we have to be careful. They're going to do what's called a partial sum. Partial sum means that you're not adding the entire list of numbers. In other words, down here on the bottom, it's not going to start with 1. They're going to start counting part way up the sequence, and then they want to know the numbers the rest of the way up. So this example right here would be, what's the sum of the 5th to the 8th terms according to the rule 11n minus 34? We're going to solve this the exact same way we solved the other ones. Your formula is right here. But the part that will be different is this n number in the front. N refers to how many terms we're adding together. So if we are adding from the 5th to the 8th terms, be very careful here. This is not 3. We are actually adding 4 terms together. It is the 5th, 6th, 7th, and 8th terms. That's 4 numbers. So you can do 8 minus 5 and get 3, but then remember to add 1 in. You're going to add 4 terms together. And then the first term plus the last term. Take your bottom number of 5, plug it in. 11 times 5 is 55, and 55 minus 34, 21. Plus, now take 8 and plug it in. So same as we did before. Take the bottom number, plug it in. Take the top number, plug it in. 88 minus 34 is 54, and then cut the whole thing in half. Answer should be 150. And then this next one, partial sum, we're adding from the 3rd to the 9th terms. So how many terms are we actually adding together? 9 minus 3 is 6, plus 1, we have 7 terms. The value of the first term, plug a 3 in right there. Negative 7 times 3 is negative 21, plus 20 is negative 1. Plus, plug in a 9. Negative 7 times 9 is negative 63, plus 20, negative 43, all over 2. And this answer ends up being negative 154. It will happen sometimes that you get negative values for sums. That's perfectly fine. If your numbers are going down in a sequence into the negatives, when you add them together, it is very likely that you will get a negative for an answer. All right, I do believe that's it. So 2 formulas that you have to make sure you have in your notes and in your cheat sheet. The first one, or the second one actually, is your summation formula. And then the first one is your explicit formula for an arithmetic sequence. Oops, where is that one? Right here. A sub n equals dn plus a sub 0. All right, there you go, section 12.2.